Hey everyone, I'm super excited to be here at the GraphQL Summit talking to you about my favorite topic, error handling in GraphQL. First off, I'm Sasha Solomon. I used to work at Medium doing GraphQL, and now I work at Twitter still doing GraphQL. Of course, coming from taking the first steps in GraphQL to a place where it's in full swing is a lot different. But one of the things that was the same was error handling. So let's start off like we would any good talk about GraphQL with a GraphQL query. So here we're just going to query for our user with username Ash, and we're going to query for an ID and their name. So let's just run this query. And cool. We get what we would expect back. We get the data and then user ID name, Ash Ketchum. So everything worked out. We get what we expected. So as you may know, canonically in GraphQL, any errors that happen are stored in the errors array. They end up there by default on any GraphQL response. This is what you can expect when you're first using GraphQL. So you're brand new to GraphQL, you first start using it. If you encounter any errors, they'll be by default in the errors array. So let's just kind of take a look at what that might look like when something perhaps goes wrong. So let's make that same query. Username Ash, and query for their ID and name. So we'll run it, and we'll get something like this back. So as you can see, we still have our data field, user is null, and then we have a bunch of things in the errors array. So this is trying to tell us that something happened, and we can kind of start to pick out what maybe happened, but it's a little hard to unpack. So if we look at this, we can see path, and in there we see user. So I guess something happened with the user. Then locations is trying to tell us exactly where this error occurred in the query. So line 2, column 3. And then we have some stuff in extensions that tells us a little bit more about what's going on. We have a message there, object not found. That's not super useful. And then the type of this error message is, the type of this error is 2. So what exactly happened? We actually don't really know what went wrong. All we have from this is object not found. That's not a great error message. And it's kind of just hard to know what's going on. For example, if we queried for multiple users, we might not know which user this is actually for without some digging and reading into this a little more, like what line and column it is. And then also for multiple errors, they would appear in the errors array also. So we'd have this whole thing with user, locations, extensions, et cetera, et cetera. But then we'd also have like a whole nother thing if we queried for multiple things and got multiple errors. So this is kind of how you get started with error handling when you first start using GraphQL. And it's kind of a lot. If you're brand new to GraphQL, it's brand new to you. It's kind of hard to pick out what's going on when you actually get an error and like what do you do with it. So let's kind of look at kind of what we just saw. So for one thing, all errors are treated the same. So all the errors, any error we get in GraphQL is going to end up in this errors array, no matter what kind of error it is. So they all end up in there. The other thing is, it's kind of hard to know where the error came from. When we were looking at that errors array and looking through it, it was kind of hard to tell like what exactly happened. We knew it was because it was a simple query, that it was the user, and we knew exactly which user it was. But for more complex queries, it's going to be a lot harder to figure out where the error came from, and especially if it's a list of things. And then also, it's kind of hard for the client to know what errors to care about. So when you're querying for this as a client, you get all the errors in the errors array. So it's actually kind of hard to know which ones are important and which ones you can ignore, which ones you care about and want to deal with. So that's kind of a bummer too. And through all of this, basically, the client doesn't know what to display. Like that's what's most important, like showing to the user, like, what went wrong or like displaying something for them. And with that errors array, it's kind of hard to know what to do. So before we get into any like solutions or talk about anything like this, let's just talk about what is an error. So let's like think about some errors. So things like when we think about errors, we think of things like maybe internal server error, deleted user perhaps, bad gateway, unavailable in country, suspended user. So these are kind of things that we think about when we think about errors. So it doesn't seem like all errors are the same though, all those errors that we just listed. So when I think about an internal server error, that seems pretty bad, not great. But that doesn't seem to be the same as, say, a suspended user. Those seem like a little different. And then also things like bad gateway, that's not great either. That's pretty bad. And there's not a lot you can do when you're trying to recover from that, especially for the client. Like, what do you display? So that doesn't really see the same as an unavailable country. That seems like something that's maybe more normal that happens. So it just seems like those aren't the same. They're not the same severity. They just don't seem the same type of error. So that kind of leads us to error categories. So let's try to categorize these errors. What's different from them? Um, so things like internal server error, bad gateway, and then deleted user, unavailable in country, suspended user, kind of starting to group these. So these things seem more like errors, like something went wrong. This is not great. And then these things seem like maybe something didn't go as wrong. So something went wrong, nothing went wrong. So those seem kind of just like different to me. And then kind of when we think about it more, these really seem like errors, like something actually went wrong. But these other things, nothing really went wrong, but they're not errors exactly, but their results just not exactly what we wanted them to be. But we queried for, say, a user. We got something like a user back, just not exactly what we wanted. So when we think about that, it's kind of like these aren't really errors. We have things that are very clearly errors and things that are just kind of um, some different kind of result, really. So, but maybe that's a lot to take in right now. So let's walk through why. So let's kind of walk through an example of what happens with something that we just categorized as an error. So first off, here's our cute little client here, and we're going to make a request to our GraphQL server at the GraphQL endpoint. There's a little GraphQL server, and it's going to talk to, say, some service or something. But let's say that something is going on with that service. It's like on fire, not doing great. So if this happens, we might get something back from that service that says, 500, like, don't talk to me. This is internal server error, bad. And so from that, and it gets to our GraphQL server might throw an exception, and that might end up in the errors array. So that's going to be some sort of message like server error, maybe something a little nicer than that. But basically, this is going to end up in a 500 back to our client. So cool. That's pretty clearly an error. And there's not a lot the client can really do when you get a 500 except try to, throw a nice page up there or something that says 500. But the client doesn't really need to know anything else about that in order to display something. So when we think about that, we would kind of say that when we get errors, things that are in this errors category, it kind of means that we couldn't get the data that we actually requested. So we didn't get the data we asked for some reason. So like in the case with the internal server error, basically that's bad and the client can react accordingly. But basically we asked for a user, some data, and we just didn't get that back. So that seems like an error. So let's talk about what we kind of just called results. So let's go through this. So we have our client. We're going to make a request to the GraphQL endpoint, which is going to hit our GraphQL server. And then that will make a request to some number of services. So maybe we asked for like a user or something. And this, our service will send back something like, like a user unavailable in country, or, whatever, some sort of something back. So when it sends this back to our GraphQL server, and then our server sends something back to our client, you might get something back that's like a suspended user or unavailable in country. So basically, it's just telling the client, like, display something, but it's not actually an error. It's not something that actually went wrong. It's kind of like, oops, but, we'll still display something. We'll say that that user is actually suspended, or, this is not available in your country, or whatever. Basically, whatever it gets back, the client behavior might change based on that. So we can actually make decisions based on what this service gave back to us if it's not something like a 500. It's something a little different. So when we think about it in that way, these are sort of not what exactly we asked for. They're really results, or maybe like alternative results. And so when we think about it that way, we did get our requested data. We asked for a user and we got some type of user back. If a user got suspended, the client might want to display that the user was suspended in something like an interstitial or something. So you might be saying, hold up. I asked for a user, but I didn't get a user back. How is that the requested data? And fair, you did ask for a user and you didn't get the actual user back. So it doesn't seem like you actually got back the data that you requested. But I will say that we did request a user, but don't we care about these other states? Aren't these things just different states of an entity or a user? So things like suspended user or deleted user or blocked user, these are all just kind of different states of a user, but they're still users. A blocked user is still a user, a deleted user is still a user in a database somewhere, and a suspended user is still a user. So it seems like if we should be able to query for these if we care about them, right? So of course, and if we've learned anything from GraphQL, it's to ask for what you care about. That's like the number one thing. Clients get to ask for exactly what they want and what they need, and then you can get that back. So it seems like if you want to query for a user and you actually care about what that is and want to display it, we should be able to model that in the schema. So let's see how we might model that. Okay, so the schema, because who doesn't love union types? I love union types. They're really cool. So let's take a look at how we could use those and utilize those. So first off, let's say we have a user. So we have a user, but let's think about the other states of a user, right? That's what we're kind of interested in here. So we can have a user or say that user is deleted or is blocked or is suspended. So these are all possible results we could have for a query for when we query for a user during just like a normal operation. So when we think about this way, really our user is a user or they're deleted or they're blocked or they're suspended. So really that's kind of like a user result. We could say this is a user result. You can get a user or one of these many things that are different states of user. So really a user result is a user or they're deleted or that user is blocked or that user is suspended. So when we model things this way, it's actually kind of cool because now we've actually encoded all of these user states into our schema, and now we can query for them, which makes it pretty easy. What's also cool is we can actually customize what each of these results looks like. Obviously it's not going to be a perfect user, so it might have some other fields on here. So something like maybe on deleted, we just have a message saying why you're deleted or whatever, maybe why they were deleted, or if they deleted themselves or something. For if they were blocked, maybe we can have a reason and maybe some other things on that about specifically why. Maybe it's an enum. And then if they're suspended, maybe we can have a link to the policy violation or in other fields like related to why they were suspended. So that's kind of cool. So we have all these different states of a user, and we can also kind of list out all the different things that are related to the states of the user. That's kind of nice. So let's look at what this looks like in GraphQL SDL, which is the schema definition language. And you've probably seen this before. So it should look maybe pretty familiar. So here we have just a user and an ID and a name, and the ID is obviously required. Cool. So then what we can do is we can actually make other types that are going to be the different states of this user. So we can have suspended, we can have is blocked, and we can have something like unavailable in country. And you can kind of see how we're starting to sort of model these. So for suspended, we have just a string that just explains the reason. You can type it in there. For blocked, it's going to have also a message, but then maybe we can add something like you were blocked by this user, and you actually could query for who they were blocked by if you needed to. And then for unavailable in country, we'll have a message about what that means, but also maybe the country code for where it was blocked. So you can kind of start to customize these, which makes this maybe pretty useful for a client. And so when we take all of these types, we put them all together and we create our user result, which is a union. So this is a user or a reason why we can't get one normally. And that's going to be the types we just defined. So user is blocked or suspended. We're not going to do unavailable in country because that doesn't make sense for this user, but That's pretty sweet. So what's cool is we can now query for this. And the coolest thing is that clients only need to query for the data that they can use. So here we have our query. We have our user result. We're querying for Ash again. And this time we're going to query for user. And then if we don't actually get a user back, we're going to query for is blocked and then also suspended. So this is kind of how this works. If you've seen this before, if you use GraphQL a lot, you've seen this notation, but the ... we're just saying on a user. So if we have a user type, we're able to query for ID and name on a user. We're able to query for message and blocked user on is blocked type, and obviously able to query for reason on a suspended type. So that's kind of what that notation means if you haven't seen it. So that's pretty cool. So in this case, we don't care about the any other things that you could query on a user result, so we're not going to query for them. So let's run this query. And we get something like this back. So in this case, this is like the happy path. We just get back a user result, and we also get back ID and name. You may have noticed that we also queried for type name. This is, you don't have to query for that if you don't want to, but this is just letting us know that the type that we actually got back is user, and that's GraphQL's way of kind of telling you for union types what type you have. So in this case, it's a user. So that's pretty sweet. So let's take a look at what happens when we get something back that we maybe didn't want, not a user in this case. So I'll run that same query and we'll get something like this back. So in this case, the query is exactly the same, but instead this user was actually blocked. So we can see that here in the type name is blocked. And then we see the message is user blocked at Ash. Okay, looks like Brock and Ash are maybe having a little fight or something. And then we actually also queried for blocked by user, and we can see that Brock has blocked Ash. So that's really cool because the query didn't change, but the results that we might get back might change depending on if someone blocks someone. And we can see this all here. We don't have to dig around in the errors race. That's pretty cool. So lastly, those are the two. First case is the happy path where everything is great. We get a user back as we expected. The second case is getting a different state of that user, which is blocked. So let's just look at what happens with our unexpected errors, the errors we'd seen before. So something bad happens. So let's just run that same query again. Cool. And cool. So now we get our this kind of what we saw before back. We got data user null, and then we have an internal server error, path user, and we have our location line and column stuff. So okay, so you might be like, okay, what about these fatal errors? Like, is there anything we can do with that? These will still happen, but that's okay. We haven't encoded these because these are unexpected. It's actually kind of hard to encode in a schema. Like, oh, if we get a 500 for this, that doesn't really relate to the user, it doesn't really relate to an entity, so it doesn't really make sense to encode it in the schema. So we won't. And so it's okay that these end up here. There's not a lot that the client can do in terms of like displaying something different for the user who's using this. So it doesn't really make sense to encode them. So that's okay. So what have we learned so far? With this new scheme, we've learned that results are customizable for each entity. So that's pretty cool. So like a user can have different alternative results than other fields. And we can also add different errors and customize fields for each type. So that's pretty awesome. For the other thing, we know exactly where the error came from. It's encoded in the schema, so that's pretty sweet. When we query for a user, we know what if there were any results attached to that entity because they were right there in the schema. So it's because it's all encoded in the schema, we are able to capture those errors, those alternative results right there and like handle them. So that's also pretty sweet. And then lastly, the client gets to decide what errors it cares about and what errors it can ignore. So that's pretty cool. So a client with union types, a client can query or not query for different errors. We didn't query for unavailable in country. We were only querying for is blocked and suspended. So that's pretty sweet. So what that means is like if a client doesn't actually care about certain types of errors, they just don't have to query for them. So that's pretty nice too. So let's kind of look at maybe what happens when our schema is structured just a little bit more complex. So here we have our user result union as we did before. So our union is a user, or they're blocked, or they're suspended. And this is that SDL that we had before, our user, and then suspended is blocked, unavailable, and country types. So let's add some more stuff. So let's add something called profile image. So we'll do kind of what we did before. We'll add a new type called profile image, and then we'll add different states of that profile image. So things like maybe flagged, maybe this profile image can be hidden, things like that. And we can add a bunch more if we want, but we'll only do these. Cool. So we added those. So now we'll make, just like we did before, a union, but this time we're calling it an image result. So this is an image or a reason why we can't get one normally. So an image result can be an image, or it can be flagged, or it can be hidden. So we can get any of these types back. So let's look at how this might look all together. Cool. So this is everything all together, and this is what we can. This is what this looks like in the SDL. Cool. And the other cool thing is, this is what we're going to do right now is, so we have these two different types and two different result types and all of the different states they can have. And what we're going to do is we're going to actually add a field called image result, called profile image result with the type image result to our user. So now you can kind of see that these results can intertwine, and that would totally happen. A user obviously would have a profile image, so this would be a profile image result. So yeah, well, what we can see here is that we've added additional result types for our new object type. So we have new results for image, and now we have image result, which was similar to what we had with user result, and now that is a field on user. So let's take a look at what a query might look like. So again, we have our user and all of its different states in a user result, which is a union, and then we also have a profile image, and it's a profile image result, and that's on a user and all of its different states. So let's kind of see like what a query for that might look like. Okay, so we have our user result query like we did before, query for that type name just in case, and then we're going to query for user like we did before in our other queries, and we're going to have ID, name, and then we're going to query for profile image result, and then all the different states that could have. So a profile image result can be either an image, it can be flagged, or it can be hidden. So we'll query for all that there. And then for user, we're just going to query for user and if they're blocked. So let's kind of zoom in on that because I know it's a little small. And we can zoom in on your own computers. So let's take a look-see. Okay, so we can kind of see this a little clearer now. But it's not that much different than what we had before. It's kind of very similar to what we had for a user. We're just doing kind of the same thing, just different types. So cool, let's run it. Sweet. Cool. So in this case, this is the happy path. We got our data back. We have our user result. And this time we got a user back. It's Ash. And we also have their profile image result. And the type name there is image. So we got their image back and we just queried for their ID, the ID of the profile image result. Cool. So you can kind of see how this would look. And what's great is that all this information is right here. And this is the happy path. We know it's an image. Cool. So again, let's go through and see what happens when we don't get the user and profile image exactly how we wanted. So let's run this same query again and see what happens, but maybe something's wrong with our image. Okay, so here we have our result back, our user result. We still have the user back with the ID and name. And this time for profile image result, we see we didn't get an image back. We actually got a flagged image. And the reason is because it was a copyrighted image. So I don't know, Ash is putting up some copyrighted images, probably Pokemon or something. He's not supposed to do that. So the reason that this profile image has been flagged is because it's a copyrighted image. So what's really cool is that this is all in line here. We asked for this, there's something wrong with the image, and the client can display a copyrighted image or whatever based on what they got back from this query. And they don't have to dig around in the errors array. So that's pretty sweet. So let's just kind of go through again what we've learned here. So again, results are customizable for each entity. So a user can have different alternative results than other entities will, and we can add different errors and customizable fields for each type. So we did that for user, and then we did that again for image. So that's pretty sweet. It's great because we know exactly where these results came from. We know exactly what errors in the query, what the errors were in the query, because they're attached to the entity. So whenever there was an issue with a user, we knew exactly what the problem was because it was right there next to the user. For an image, when it was a copyrighted image, we knew what the issue was because it was right there in line as a part of the result of our query, which is pretty awesome. And then lastly, the client gets to decide what results it cares about and what results it can ignore. So because this is all queries, and then because this is GraphQL, as a client, you can query for what you want and what you don't want, as long as it's and not query for what you don't want, as long as it's in the schema. As long as it's encoded in the schema, you get to decide. So if you don't want to get all of those different types for a result back, you don't have to query for them. You can just query for the image, or you can just query for the user and don't care about anything else. So you as a client get to decide what's important when you're writing your queries, which is kind of the whole point of GraphQL. And so what we learned also is that errors don't cause failures in nested queries. We were able to query for 2 different result types, and when one failed, it didn't cascade and fail the entire query. This is a problem that I have experienced personally in the past. It's a real bummer when you query for one thing and then something inside a nested query like fails the entire query out. So these types of results don't actually cause these like nested cascading failures. The other thing is that we can kind of tune how verbose we want these results to be. We can add result types to any entity we want, kind of like we did with user and profile image, or not. We don't have to. We get to decide what we want this to look like. We can add a bunch of stuff to each of our results, or we don't have to add anything. We can just add a field, or it can just be a type. It doesn't matter. We get to decide how this is encoded and how this is in our schema. And then also, we are able to basically more accurately represent our data. By doing this, our schema structure actually mirrors what our data looks like. If we have a user and the user can have all these different states, it kind of makes sense that they would be attached to the entity and encoded in our schema. And when it's like that, it's much easier to reason about. When I'm querying for a user and I want to know what the different states are so I can display them properly. So it makes it a lot easier to reason about this stuff when it's all encoded in the schema and you can kind of look at what this data looks like. Maybe you might be thinking this, but there are more than just 2 categories of errors. I just displayed these for you today, just so you can kind of take a look, but there could definitely be more than just errors and things that are results. But our alternative results are kind of like a good way to start thinking about what could be returned and start thinking about how we could maybe model some of these things that might not actually be errors in our schema. So I'm sure there's bunches of different things. We're just not covering them today. And then the other thing is you can customize this as much as you want. That's kind of what's cool about this, and what's kind of cool about GraphQL is that you get to decide what you care about and what you want to customize and what you don't. If you don't care about half of these states, you don't have to put them in the schema, and as a client, you don't have to query for them. But you can also add new types of results. So that's pretty sweet. So what did we learn? Well, we learned that not everything is an error. And we've also learned that you can model your errors as errors and you can model your results as results. And the other thing is results are actually things that you want to display, which is awesome because we can actually encode these in the schema and we can query for them. And as you may know, the GraphQL spec intentionally does not prescribe how we do a lot of these things. And this is also true of errors. So it kind of gives us the flexibility to design our schema and design how we want to handle errors, and in this case, results. The fun thing is this talk has actually been all about results. I tricked you. It's not about errors at all. And actually, it's really about schema modeling, thinking about your data and how it fits in your schema and really like tailoring that to what you need. And I think results can kind of help with that. So one thing Medium. I used to work at Medium, and we are actually using this, Medium is using this functionality in production right now. And it's actually helped a lot to avoid the error types that we were encountering before, especially that cascading issue. Those are all things that we've used this before, and we've dealt with this before, and it's being used now. And this is why we've kind of like thought about results a lot. I work at Twitter now, though, and we're trying to work on using this functionality in the future. It's a lot more complicated at Twitter, so it won't look exactly like this, but we're using something similar. So I hope that you've seen how we can approach error handling and how we can deal with it with different classes of errors, especially when they're not errors at all. We can model things in the schema, and maybe they're just results. So I hope this has been really helpful for everyone, and thanks for coming to my talk. Hey everyone, hope you enjoyed the talk. And it looks like we have a ton of questions, and I think we don't have a ton of time to answer them, but I'm going to try to answer as many as I can. So I'm just going to get right into it. So first question is, in the case of 500 type error codes, do you still recommend individual error types? And that question is from Kurt. And yes, basically anything that's like an unexpected error, I would say like continue to use the like error codes or put them in the errors array. It's mostly because it's hard to encode things in the schema that you don't know about yet. Like 500 errors would be kind of hard to encode in the schema, especially when they happen for like any sort of thing. So yeah. Let's see, next question. Do you have a linter check on Twitter that detects that all mutations handle all possible errors? And how do you know, or how do you handle new members to union types to avoid ignoring new errors? And that question is from Unwanted Crow. So yeah, I think one, we're trying to kind of build out things to help detect when, like, which union arms were handled and which weren't. But also, we only would want to do that for cases when clients would need to absolutely handle all of those cases, and it's really important to. But part of the like cool part of this design is that you, as a client, you don't have to handle all of those cases if you don't want to. In some cases, we wouldn't want to like add that sort of like lint check to make sure you're handling all those cases. Cool. Let's see. Next question. This is kind of a long one, and I think it's like a really good one. So on a simple query like user, number of union types required might be pretty small, but on a very complex mutation, you might get hundreds of different possible errors. It feels like you are putting the burden of knowing what types of errors onto the client. However, errors are purely server-driven behavior, and GraphQL operations are client-driven requests. How do you deal with that? How do you avoid having client operations that span a number of pages and require a huge number of fragments? And how do you avoid rewriting clients when a new error has to be added on the server side? So yeah, long question, but it's really good. So one, yes, like I kind of touched on this in the previous question, but the clients will need to know what errors to handle, but they kind of need to know this anyway. So like, for example, for like a suspended user, as a client, I would want to know, if that user is actually suspended, and then, I have to display that somehow. So I already need to know pretty much all of these like different like entity error result types. So it's something that I need to know anyway. So it's kind of not necessarily a burden. It's like really useful because you must handle a lot of these things. And when you add new like union arms, yeah, you'll have to rewrite parts of your client. And I think maybe I didn't quite touch on this in the talk, but if you're using union types to handle errors or results, you'll definitely need some sort of like default case. So for a client that is like you have like certain error types or result types, and then you'll have like a default kind of catch-all case just in case one of those, like, you get some sort of new result type that you don't expect. And that's great for when you get like a new client. The older clients aren't able to support new union arms. So then they have this default case. So that's really important anytime you're using unions just anyway, because if you do get something unexpected, you wouldn't be able to handle it. So that's kind of like an important piece there. And then the last one, do you think this pattern would make sense for authorization errors? Having a union with type unauthorized for any part of the schema the current user can't access. This is an interesting question, and I think yes. In some ways, kind of like authorization errors are sort of like different states of an entity. And I think this sort of like union scheme could be used for maybe authorization errors. You can think of maybe some other errors, maybe like rate limiting. Those things we haven't been using, but I could definitely see being able to use this for those things. Okay, I think that's all the time I have. So thank you everyone for all the questions.